Let's take a look at the service mesh, and in our case specifically, let's take a look at the example of the Istio. So let's say that we have API gateway, right? So we have API gateway, and the API, so we are receiving the request to our API gateway, and what we do is, and we have in our system is basically three microservices, right? So we have microservice 1, microservice 2, and the microservice 3, and they have different instances. We have different instances of those microservices, and from the API gateway, we are routing our request to one of these microservices. But besides sending a request from the API to the microservices, these microservices also communicate with each other. For example, let's say that this first microservice, right? This microservice fetches data from this microservice and also fetches data from third microservice and the third microservice from the second microservice and so on. So there is a communication between these microservices. And if we are communicating between microservices, so what we need to do is we need to authenticate, right? So we need to make sure that the request is coming from the right microservice, so that microservice authorized to fetch the data. And also things like a logging, retry, and so on. So we need to implement that for each microservice. So in order to avoid those problems, in order to not to repeat the same logic in each microservice, service mesh is used. It's a tool. Service mesh and specifically Istio is used as a tool. So what we do instead of for this microservice, right? Let's take a look at this microservice. Instead of for each microservice implement the logic of the retries and the authorization and so on. So what we do is we are using a tool, a proxy tool. In our case, in case of the Istio, we are using the Envoy, right? So what it does is it takes care of all those parts, right? So Istio itself, for example, it has two parts. It has the control plane and it has the data plane. Data plane uses the Envoy. So what it does is Envoy is basically a small part of for each pod, right? In our case, for each pod, we are adding a proxy layer. So all communication between these microservices goes through that proxy. So let's say that we have our logic here in this pod, right? But the communication between these microservices goes through this pod, through this proxy. So that is called the data plane part. But also we have for things like a telemetry and so on. So we have another part which is the control plane. In the control plane, what we do is for the control plane, it handles things like a logging, also traffic to the newer and the older version of the microservice and so on. That's in a nutshell what is the service mesh and the Istio. Now let's go take a look at the specific use cases. So a specific use case, in our case for service mesh, we are taking the example of the Istio, right? So what we do is from the client side, when we are receiving a request through the API gateway, through our entry point, we are sending to our microservices. Again, in our microservices, it has two parts, right? As we have seen earlier, it has two parts: the data plane, which is that we also call them sidecars. So you can think of them as a proxy layers, right? Small part of the small proxy that we are adding to each pod, to each instance, to each microservice. So it handles things like routing, retries, circuit breaking, for example, TLS certificate metrics, and so on. Also, we have the control plane. Besides the data plane that we are adding to each microservice, to each pod, we have also on the tool level, on the Istio level, we have another part which is the control. It handles the traffic control, which means that to each microservice to send let's say we have two versions of our microservice, two version of our pod, and it controls to which pod we should send what percentage of our traffic. We can configure that. Also, we have it handles the security, and also it handles the telemetry, such as the metrics and the logging. So let's go and so which tools we are using, right? So for example, in this case, for the traffic control, we are using Pilot. For the security, we are using Citadel, and for the metrics and logs, we are using a telemetry. So where else we are using Istio, right? Else we are using a pilot. So for example, let's say that for the deployment, specifically, let's say that for the canary deployment in the microservices, we can use the Istio. So for example, let's say that in the canary deployment, we are starting with we are gradually increasing the traffic to the newer version of our application. So that part we can do with that part we also give that responsibility to the Istio. If we compare that what we had and what we have after introducing the Istio in our microservices system, so let's take 4 parts, right? Let's say that the routing, security, observability, and the resilience. For the routing, before what we had is we had the hard-coded hard-coded values in the each application. So we have replaced that with the declarative YAML config. For the security, we had to change the certificate manually. So for that, we have the auto TLS certificates change. We are using Citadel for it. For the observability, we used to have a custom logging, but now we have a built-in metrics and the traces, which is centralized, and we have a resilience. For the resilience, we had a library-based retries, but now our retries we have a transparent retries and the circuit breaks. So what are the key benefits after introducing the Istio? The key benefit is that the first one, we don't have to manually change the certificate, so zero trust security with the auto TLS. Also for the traffic management without the code change, so we don't need to add any specific traffic routing or the logging or the circuit break or let's say the retries logic to each microservice when we can only focus on the business functionalities of the microservice. So also we have a full observability with the minimal efforts. So again, we have the because the logs are centralized, we have a full visibility to each of our microservice without adding the custom logging and without doing all those parts manually. And also we have the Kubernetes native integration.